So as you guys look at this, is this an observational study or an experiment? It's an experiment. And how do we know it's an experiment? The treatments, and what were those treatments, by the way, you guys? It looks to me like placebo and a drug. I'm going to call it the drug group, if that's okay with you guys, rather than me trying to pronounce that drug, which is not in my wheelhouse. So if I were to ask you, is something an experiment, you want to describe the treatments in context. Okay? Okay. Why is it important that we look at if we have an experiment versus an observational study? What does that say about our conclusion? If the treatments were randomly assigned. That's not true. Not for randomly assigned treatments. For randomly selected samples, I totally agree with you. Okay? But not for randomly assigned treatments. Instead, because here's the deal, you want to ask yourself, is the people that are the people that this experiment was on similar to the general population? They recruited middle-aged men with high cholesterol. That is not a random sample. Do you guys get what I'm saying here? And so we won't be able to make any conclusions about the general population here. What we will be able to conclude is cause and effect. So if we see a significant result, which by the way would be the equivalent of a low p-value, okay? If we see that significant result, we'll be able to conclude cause and effect. Is everybody good so far? That the gemfibrozil, it's close, right? Gemfibrozil. If I said that with more authority, you guys would just believe that's how it's pronounced, right? The gemfibrozil? Right? Totally, that's what it is. Okay? This medication, if we see that difference, works. Period. End of sentence. Do you guys see what I'm saying there? All right? Now, do we have a random sample? No. We recruited men with high cholesterol. And the way that influences what I'm allowed to conclude, I can only conclude about men similar to the ones in the study. All right, so let's go ahead and run the test all the way through. All right, so when we do this drug trial, right, the first thing we would do is start with our hypotheses. What would they be? Last page, Brody. Talk to me about my null hypothesis. We have two groups, yeah?
P1 minus P2 equals 0.
And again, I always avoid P1 and P2, so I'm going to do, just because I've seen some rubrics on the AP exam, some rubrics actually give you credit for context by just using the subscripts. Not always. So we're going to still define it in context, but on the off chance that, yeah. And you guys, what's my alternative going to be? So we got to, in this case, because we started with the placebo group minus the medication group, okay, we're hoping there's more heart attacks in the placebo group than in the gemfibrozil group. Does that make sense? And don't worry, I know that I just said we're hoping that there's more heart attacks, but that feels kind of icky. But in order for this new medication to be approved and work, is that we're hoping the placebo group has more heart attacks than the medication group, because then we can maybe say that the medication worked at lowering heart attacks, right? Okay. And from here, I might say PP is the true proportion of heart attack for the placebo group. And then you're going to do like PG equals the same true prop of the other group. What do we think so far? And if these are our two hypotheses, which procedure would be appropriate for us to test these hypotheses? It is a two-sample Z test. Because we're not making the estimator, we're trying to test whether or not this hypothesis is true. And to run that test, we have to check our conditions. Cool. Normal. This is, of all the conditions for any test I make you guys do, this one's the worst one. Okay? So before we can do the normal condition, let's go ahead and look at our p-hats. So what is our p-hat for the placebo group? It's going to be 84 out of something, but I can't see up top, so can you guys look up top and say how many people were in the placebo group? 2030. Okay, and then the medication group would be 56 out of 2051. So can you guys help me out with that? Maybe help me out with that out to 3 decimal places, please. Thank you. So, you guys, what that says is did I have this backwards?
No.
I was going to say the placebo group should be the higher one for sure. You guys, did the placebo do better than the medication? Or, I'm sorry, not do better. Did the placebo have more heart attacks than the medication? Yeah, for sure. A lot better? You guys, I'm going to give you a hint real quick. You ready? If I say a lot better, your answer should always be, I don't know. Let's see how much better it did. Because the decision between a lot better really should depend on your p-value.
When you're saying better, like, you're saying that the placebo is better because it did more heart attacks?
No, I'm saying, okay, so is there a difference between the two groups? Yeah, for sure. Is it a big difference? That's probably a better way of phrasing it. Okay, is it a big difference between the two groups? Some people would look at this and say, oh, the difference is about 0.014, 1.4%, which doesn't feel like that much. But what if I were to say the medication group had barely more than half as many heart attacks as the medication group? And heart attacks themselves are a relatively rare phenomenon in middle-aged men. Do you guys get what I'm saying here? And so what is a lot is a kind of a weird question to ask. Okay? So the way we make that decision is we run the test. So we're going to go get our z-score. We're going to get our p-value and let that answer that question for us to decide, is this a big difference or not? Okay? Let the p-value make that decision, not the... All right. So you guys, we did all of this so that we could answer this normal condition. And I'm going to take you through this reasoning again to kind of just help to iron it out, okay? Are you guys with me? That my null hypothesis is that both groups are equal to each other. And I could argue that my null hypothesis is essentially saying that the medication doesn't work. Right? And that all of these men were going to have heart attacks regardless of whether they took the medication or not. Does that make sense? So if I wanted to estimate the true proportion, if the null hypothesis is true, my best sample to estimate the proportion of middle-aged men who are going to have heart attacks because the medication didn't work, right, is going to be a giant sample out of, let's see, total, we had 4,081 men, and the ones who were going to have heart attacks either way, there's 140 of those. And all I'm doing was adding those together, both the sample size and the number of successes together. We're making one giant sample. And, I'm sorry? 0.034. Are you guys with me? That seems about in the middle-ish. It's not perfect because the samples were different sizes, okay? And for everything we do in the test, we're assuming the true proportion is true for both groups. This is my best estimate of what that true proportion would be. Never mind, I have a sneeze. It's right there. I'm certain that it's the dust from the middle school being kicked out. Is anybody else having allergies in the building? Just me? Okay. All right, so we'll do that 2,000. So what we're doing is NP and 1 minus P for both samples. It's just that the P hat we're going to use is that 0.034. Yeah, that's what I said. 0.966. Does that feel right?
Sure.
And we're going to figure out what are those numbers. We doing okay? And maybe say, hey, those are all greater than 10, we're good. If that normal condition is met. Okay. Lastly, for our conditions, we're going to do the independent condition. Your gut is going to tell you to say, oh, 2030 and 2051 are less than 10% of the placebo group? That doesn't really make sense. Because they're not. They are the entire placebo group. Do you guys... Okay? So instead what we're going to say is individuals' responses to the treatments are independent. All right? To think through the how and why of that, imagine Mr. Richards has high cholesterol, so he goes and he's taking one of the two medications, okay? As does Mr. Rummer. Both middle-aged men. Is whether or not Richards gets a heart attack going to be related to whether or not Rummer gets a heart attack? Probably not. They're not related to each other. Okay? Whatever happens with Richards is independent of what happens to Mr. Rummer. Everybody good? Now's the fun part. We just have to do the boring stuff. Hey guys, can you help me? I want to see what you remember. Can you guys find the z-score and the p-value for me in your calculators? Yep. Ooh, no. We don't have enough information for that. So this is when you use the test menu and you hit stat, arrow over to tests. I don't know.
2.4
2.47?
I got negative.
2.407.
40. I got 2.470.
I got negative 2.4.
Okay, so here's what happened with you. You put the medication group in first.
Yeah.
Except for because of the way, And that would be fine. But because we wrote our hypotheses with the placebo first and the drug second. So your p-value, I bet, what was your p-value?
0.01.
2.47. What confidence, does it say?
See, this is fun. This is what I was going for. Okay, you guys. As we're going to make these decisions. Okay. You're going to hit stat. You're going to go over to tests. All right. And then you got to pick which one to do. Is everybody with me? So this is where we're telling the calculator all the information that we've already calculated. Okay? All right. So which one do I need to pick? First of all, the name of my procedure was a 2-sample z-test for 2 different proportions. Yes, this is a test, not an interval. You with me? So when I go, I want to look for something, since it's for proportions, it should have the word prop in it, it should have the word 2 in it, and it should have the word test in it, because those are my different procedures. Knowing that, anybody want to guess what I should pick? Option 6. So let's go ahead and go to option 6. Okay? And then it's going to ask you for your x1 is going to be 84. The values that you put in for p hat, those are those values, right? So my x2 will be 56. My n2 will be 2051. Everybody good so far? Okay, now Vivi, what's our alternative hypothesis? Just look, we're right here. It's here, yeah?
Yeah.
What sign is that?
Greater than.
Okay, so for this last piece where it's asking me which is my alternative hypothesis, I need to pick the one with the greater than sign. Cool. I got that from what your p-value was. That's the only reason I knew that. So, I picked the wrong one. All right, so I picked greater than. So that is one of the things you want to make sure you're double checking. All right, and then I hit enter. Go down to calculate. And you guys, I got a z-score of 2.470. And a p-value of 0.0067. So I'm going to ask you guys again, is the difference between our 2 groups a lot? Yeah. Because what do we know about a low p-value? What would that make us do? If my p-value is low, what do I do? Do I read?
You don't reject.
You do reject if it's low.
You do reject it.
You do reject if it's low.
Okay, this one is greater, that's what we affect.
Okay, so from here, we're going to say since you always start by comparing your p-value to alpha. All right, and if I reject the null, what am I allowed to conclude? The alternative. Now, I want to go back up to those 2 questions we started with here, way up here at the top. If I'm concluding the alternative, I'm saying there is a major difference between the 2 groups, okay? But more importantly, I'm concluding cause and effect, but only for people like the guys in the study. Okay? So the way I might write this particular alternative, and this is the first time this is really coming into play, is I might say, therefore, we can conclude that the drug causes a decrease in rate of heart attack for men similar to the men in the study. So now that we have two sample stuff, we have to be a little bit more picky. Everybody good? All right, from here, we are going to do some practice free response questions. These are all free response questions from the previous AP text. We're going to do these today and tomorrow. I'm hoping we get through at least the first one today. And I handpicked these because I feel like they do a pretty decent job of reviewing the whole unit as a whole. So, let me see.